Hey guys. Well, this is the final example, and it's actually the final example since this is the last of these you'll be getting this year. So let's read it and let's see if we can't solve it. Monique is seriously tired of watching other girls use the restroom and not wash their hands. We're supposed to be better than the boys, she screams, thinking that the boys at her school likely don't wash their hands as much. She wonders of the validity of her original thought and decides to do a two-sample hypothesis test to test her hypothesis. She has a male friend observe other males while she observes other females. She observes 18 females, and of the 18, only 11 wash their hands before leaving. Of the 16 boys her friend observed, only 7 wash their hands. With an alpha level of 5%, is there enough evidence to support Monique's original claim that females wash their hands at a higher probability than males? Well, like usual, I've copied that over here onto this doc, and we're going to use it to help us identify the hypotheses, our variables, and then to eventually solve. So let's start with the hypotheses. You can see right here that it says she believes that females wash their hands at a higher probability than males. Well, if we refer to females as 1, we can say that the probability of sample 1, which is females, is going to be greater than the probability of males. And likewise, in order to create a null hypothesis, we're just going to take this exact information. We're just going to flip the sign and put a line under it. So instead of greater than, it'll say less than or equal to. All right, and we want to make sure that everyone knows that this alternative hypothesis is our claim. Okay, in addition to that, we know it's going to be a right-tailed test because it does say greater than, and the greater than symbol does point to the right. Alpha level is the next thing we want to find, and it's usually found in the last sentence with an alpha level of 5%. So we know that alpha is going to be 5%, which is 0.05. And if you look up 0.05 on a z-chart, you will find the value to be z of r alpha is going to be equal to about 1.64. All right, now earlier we said that these are not important to solve anything, so tell you what, let's make a little bit of extra space and just get rid of them. N1, this is going to be how many females were observed, and if we look, she observes 18 females. 18. Her male friend who observed the males said that he saw 16 total. This is the number of successes for females. Well, only 11 wash their hands, whereas for males, only 7 wash their hands. Next up, we're going to find our p-hats. So remember, p-hat is just your number of successes divided by your number of samples. So the first is going to be 11 over 18. And we could find out what that is real fast. 11 divided by 18 will give us approximately 0.6 with 1 repeating. Let's call it 0.61. Next up, we have x2 over n2. Well, x2 is 7. There were 7 successful male hand washers, and that was out of 16 total. So we're going to do 7 divided by 16, which is less than half. That's about 0.44. So we'll say approximately 0.44. Next up, we're going to take both successes and both observations for both groups, and we are going to say x1 will be 11, x2 will be 7, and 1 will be 18, and n2 will be 16. This is pretty easy. 11 plus 7 is 18, so we can put 18 for the numerator. Denominator is going to be 18 plus 16, that's 34. And let's find out what 18 over 34 is. 18 divided by 34 will give us approximately 0.53. All right, we have our p hat, sorry, our p bar. Our q bar is just going to be this number subtracted from 1. So 1 minus 0.53 should give us 0.47. And again, if you don't believe me, 1 minus 0.53, there it is, 0.47. Okay, we now have all the information we need to start crunching numbers. So let's go ahead and fill this out. We are going to start with p bar times q bar. Well, p bar we just found was 0.53, so the root of 0.53 times 0.47 times 1 over n1, so that's going to be a fraction, and 1 over n1 would be 1 over 18 plus another fraction, 1 over 16. All right, well, let's go and start off by finding out what 1 over 18 plus 1 over 16 is. We can use a calculator to do that. So we'll make sure we put it in parentheses. 1 over 18. And we're going to add that to 1 over 16. And that gives us approximately 0.118. So we're going to replace this right here with 0.118. All right, next up, we are going to take 0.53 and multiply it by 0.47. Let's actually recreate this one over here. Okay, and we said this was 0.118. All right, we can take 0.53 and multiply it by 0.47 to see what we get there. So 0.53 times 0.47 is going to give us 0.2491. So we now have 0.2491 times 0.118. So let's multiply that by 0.118, and that is going to give us 0.0294. 0.0294. All right, all we have to do now is find the root of this value. We will have our answer. So, got our number, square root it, and we get 0.171 approximately. So approximately 0.171. All right, we have our standard error, which is great because that took up most of the equation. The rest is actually pretty simple. So what we can do is we can take this and just replace all of this, which is what we just found, with 0.171. P1 minus P2, we know that these right here are going to disappear, the P1 and the P2, with the P hat 1 and P hat 2. We actually know those. So P hat 1 was 0.61, and we are going to subtract from that 0.44. So let's find out. 0.61 minus 0.4447 is going to give us about 0.14. So 0.14 0.14 over 0.171. All right, let's find out what we get. So 0.14 divided by 0.171 is going to give us about 0.818. Let's call that about 0.82. And we now have our sample statistic. All right, last thing we've got to do is graph this thing out. So let's go ahead and do that. There we go. Let's grab some arrows. All right, so the first arrow we're going to set is going to be for our alpha level. Our alpha level is 645. So let's put it right around here. Okay, next up we need to put our sample statistic. Actually, let's label this one first. So we'll call this one our alpha z-score. We said the alpha z-score is 1.645. 1.645. Okay, next up we need to put our our sample statistic. That is going to be actually closer to the average here, to the mean. So let's go ahead and bring that up. And let's call this one, what did we say it was? We said it was 0.82. So our sample statistic, as we said, that one is going to be 0.82. All right, so we now have our sample statistic and our alpha z-score. If I move this one a little, make it a little easier to see. There we go. We, of course, need to identify where our rejection zone is. Well, our rejection zone is going to be to the right of our alpha z-score. So here's our rejection zone. And after looking at this one, we can pretty clearly see that our sample statistic is not going to be in our rejection zone. It's outside of it. What does that tell us? That tells us that we cannot reject the null hypothesis. And if we cannot reject the null hypothesis, we cannot support the alternative hypothesis. Okay, we know that our claim is the alternative, so therefore we cannot support the claim. So with an alpha level of 5%, we have insufficient evidence to support the claim that females wash their hands more than males. Sorry, Monique. And that is the answer. All right, guys, thank you so much for watching.